Okay, now the last question. Question number 5. Find the smallest three-digit number. This is the first requirement, which, when divided by 4, leaves a remainder of 1. This is the first remainder requirement. And the second, when divided by 5, leaves a remainder of 4. And the third, when divided by 6, leaves a remainder of 3. So this is the last type of the remainder problem, where we have neither the common remainder nor the common multiple. So we need to enumerate. And remember, your teachers must have told you during lesson that when you enumerate, we will always want to enumerate with the largest number, because the largest divisor means least work. So we look at the third requirement first. When divided by 6, it leaves a remainder of 3, meaning that if we take multiples of 6, then the number we have must be 3 larger than the multiples of 6, because only in that way we will have a remainder of 3. So we start with multiples of 6. We have 6, 12, 18, 24. So we add 6 each time, 30, 36, 42, etc., etc. Now, these are the numbers we want. The numbers we actually have is we add 3 to all of these numbers. So it's going to be 9, 15, 21, 27, 33, 39, and 45, etc., etc. So these are the numbers we actually have. Let me just erase the desired number sequence. We can just focus on the numbers we actually have. Now, we have fulfilled requirement number 3. We then look at requirement number 2. So which of these numbers, when divided by 5, leaves a remainder of 4? And you can do the calculation, you can do the division, and you will find that the 9 and the 39, they fulfills the requirement number 2 and requirement number 3 that's at the same time. So, on top of that, we just need to determine which, when divided by 4, leaves a remainder of 1. So which of them will fulfill requirement number 1? And so out of the 9 and the 39, luckily, the first one fulfills the requirement. Yeah, the 9. When 9 is divided by 4, the answer is 2 with a remainder of 1. So 9 works. How about 39? So when 39 is divided by 4, the answer is 9 with a remainder of 3. So no, 39 does not fulfill the requirement. So number 9 is the lowest, is the smallest three-digit number we can find that fulfills requirement 1, 2, and 3. But the question is looking for a three-digit number. Yeah, we cannot just put 9, a single-digit number, as the answer. No. So what do we need to do? The answer is we need to add the common multiple of 4, 5, and 6. The reason for that is common multiple of 4, 5, and 6. So common multiple must be divisible by 4, by 5, and by 6. So they will not contribute any other remainder when divided by 4, 5, and 6. So the requirements will remain fulfilled. They won't change. So we can do that by finding the LCM of 4, 5, and 6 by short division. This is lesson 11 stuff, and by the time you see this video, you should be able to do that to find the LCM of 4, 5, and 6. We can use short division, and with 3 numbers, when we find the LCM, we only stop when we randomly pick 2 of the numbers out of the 3, and they will be co-primes, guaranteed. This is clearly not the case right now, because 4 and 6, they still have common factors 2, so we need to cancel the 2. So divide by 2, divide all the 3 numbers by 2. The quotient goes below. 4 divided by 2 is 2. 6 divided by 2 is 3. 5 is not divisible by 2, so it just goes directly below, straight below. And then all the numbers on the outskirts, we multiply them together. So 2 times 2 times 5 times 3. This will give us the LCM among 4, 5, and 6, which is 4. 2 times 2 is 4. 4 times 5 is 20. 20 times 3 is 60. So the LCM is going to be 60. So we add 60, but that's not enough, because that's going to give us 69, which is not a three-digit number. So we have to add another 60. So the answer is going to be 129. So 129 is the answer. This is the smallest three-digit number that fulfills requirements 1, 2, and 3 at the same time.